All right, so the good news is that if you feel that you did well on the equation quiz yesterday, like you understood how to solve an equation, uh, this is a very seamless transition. There's a lot more similarities between equations and inequalities than there are differences. But let's analyze some of those similarities and those differences and compare and contrast. Yeah, man. You didn't get one? Oh, because Dario was in the bathroom and they didn't. It's probably because you were wearing a hoodie, but now you're not wearing it. Then you get the. All right, so let's talk about equations. How many sides does an equation have? Two. An equation, yeah. Sides. ¿Cuántos lados? How many sides does an equation have? Two. It has a left side and a right side. Hey, guess what? Guess how many sides an inequality has? Yeah, it also has two. In an equation, what's the comparative symbol that compares those two sides? On an equation, it's an equal sign. And what does an equal sign say about those two sides? What does an equal sign say about those two sides? You don't want to use the same word in the definition, so let's come on. Yes, they're the same. Yeah, exactly. That they're worth the same. So that's now one of the first subtle differences. Inequalities also have comparative symbols, but instead of there being just one symbol, there's actually four possible comparative symbols, and they all mean something different. None of them imply that two sides are exactly the same. Okay, these are the four comparative symbols. They are known as a less than sign, greater than sign, less than or equal to, or greater than or equal to. And what they do is they compare those two expressions. Okay, let's go back to a similarity. What did you do to an equation? We had those two sides, and we had an equal sign in the middle. But when given an equation, what did you do? You solve, and when you solve, what's another word that we use for solving? You isolated. You isolated a variable. Take a while. Guess what you're going to do with an inequality? We're also going to isolate a variable. Biscuit eating bulldog. And with the exception of one little step, the steps themselves are going to be the same thing. You're going to do the opposite operation. You're going to work your way outside in by doing SADMAP. The steps are nearly identical with one little difference, and we'll worry about that when we get there. Okay, so that's when you compare the solving part. Okay, but now there's an addition. Not that it's different, but there's an additional skill that we're going to tack on with inequalities that we didn't do with equations, and that's that we're going to graph. And it isn't that equations can't be graphed. It's just that we really chose not to because it doesn't add a lot of value to it. There's not much that can be gained by graphing an equation. And here's what I mean by that. When we solve the equations, how many variables did we have in the equation? Just one, yeah. There might have been more than one of them, but there was just one. All of the equations had one variable. So let's pretend that variable was x, and let's say I solve again like x equals 5. Could I graph that if I wanted to? Sure, I could. You know, because there's only one variable, we only need one axis, also known as a number line. And you might have seen these before, and then you have like -3 and -2 and -1 and 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7, blah, 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 blah. You have this number line there, right? If I were to graph an equation, what would that equation physically look like on a number line? If I were to graph x equals 5, what would it look like? A graphical representation of this solution would be to just find 5 on the number line and put a point there. Well, you're not gaining a lot of value there. You're not looking at, oh, wow, like, see here, I have no idea what's going on. But now that you've shown it to me that way, now I get it. Doesn't really work that way. Okay, but with an inequality, there's a little bit more value to be gained because let's say, for instance, instead of saying equal to, let's say I were to say x is less than or equal to 5. How many numbers are either less than or equal to the number 5?
5, 5 through.
How many numbers are less than or equal to 5? An infinite amount. Yeah, that's what the arrow means. Numbers go forever in two directions. So there's an infinite amount. And since we don't have an infinite amount of space on our paper to list all the different numbers that would be considered solutions, we can encompass them all in one little spot by graphing this and like shading in. Shading means solution. So we can give a graphical representation of all of our solutions. So in addition to solving, that's what we're going to do today. Facts. Boom. Goes the dynamite. Okay, Mama? Sorry, one more thing before we move on. When it comes time to graph, right, we're still going to have one variable. We're still going to graph on one number line. I'm going to ask you 3 questions each time we graph. The first of which is going to be, what's the critical point? Because, see, like, let's just go back and put what I had on the board here before. Let's say I say x equals 5, right? Well, if I graph that, it doesn't matter how many numbers are on the number line. There's only one number that's important, which is the 5. But if I change that to an inequality, which I did before, well, there's still really only one number that's important, and it's still a 5. The difference is what the 5 is doing. With an equation, whatever number you get on the other side, that number is the answer. It is the solution. Whereas in an inequality, that number, what it's acting as is like a divider. It's a boundary. It's breaking up the line into 2 different parts, like the good guys and the bad guys. One side of the 5 will be the solution. One side of the side will not be the solution. So all those extra numbers, all that, like, 1 and 2 and 3 and 4 and 6 and 7, you don't have to write all those extra numbers. The only number you got to show me is the critical point. So every time we graph, I'm going to ask you what's the critical point, and all you have to do is tell me what number's on the board. The second thing I'm going to ask is what's going to happen at that number, because that number can't just stay on the fence and say, hey, guys, hey, can we all just get along? No, it's got to pick a side. It's either going to be part of the good guys or the bad guys. And what tells us that is the type of inequality sign. Anytime that you have just a less than or a greater than sign, if there is no or equal to underneath, then that means that at that point, you're going to have an open point, an open circle, abierto. That means that that point is part of the bad guys. It's part of the non-solutions. Then if you have an or equal to sign, then you're going to put a closed point. So far that's 2 questions. I'm going to ask you, what's the critical point? I'm going to ask you what's going to happen at the critical point. Then the last question I'm going to ask you is, well, where do you shade? Do you shade, are the answers on the left side or on the right side? It can't be both. It's got to be one or the other. Huh? Well, we'll see. We'll cross that bridge when we get there. Let's get ready for that. Example time. Okay? So let's take what we know and build on it. Isaac is a master builder. So Isaac, when you look at this and say, hey, I know that this is an inequality, but if this was an equation, and if I were to solve this, there's only one step. So what would be the only step I would need to do in order to solve? Shush, 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 shush. Isaac, I want Isaac. Go, Isaac, go. No, but then just say it again. Go. Isolate how? No. You just, like Nike, just do it. Elsie knows? No. What do you want to do, Elsie? Boom. Take that, inequality. So Isaac was going to say that, but he just wanted to let Elsie have a moment. Okay, so, we're treating it like an equation, and just like an equation, the v will be isolated. I got my less than sign, and what's negative 3 plus 4? Is 1. So now what I'm saying is my answer, my solution, is not 1. It's all the real numbers that exist that are less than 1. And since there's so many of those, infinite amount, I'm going to represent that graphically. But instead of having to put a bunch of points in there that are just kind of trivial, I'm going to stick to just the important stuff. Here's my number line. It's nice if you want to be technical about it, and if you're going to avoid writing all those other points, you should put that smaller numbers go left and bigger numbers go right. Out of all the infinite amount of numbers in the world, what's the only important one here? The 1, because that 1 is going to act as a divider. One side of the 1 is going to be solutions, one side is going to be non-solutions. But that 1 has to also pick a side. What type of point is going to go on that 1? It's going to be open. There is no or equal to sign underneath. So that means it's an open circle. So once the teams get picked, the 1 is going to be part of the non-solutions. It's part of the non-shades. And then Lana B, am I going to shade? I know we haven't talked about this yet, but let's see. Are we going to shade left or right? Left and right? You going to do both? Okay. And she is correct. It's going to go left. But just what I find is maybe even more important than knowing where you're going to shade is why. Because that's what I found that the kids don't really have a good understanding with. Yes? It doesn't matter where the inequality is facing. If you see that little or equal to sign underneath, it's closed. Always. Well, now you teacher did. Boom. Okay? Now here's something else that, see, I honestly kind of doubt that the teacher would have teach that part. But this next part, I'm not always in agreement with the way other teachers teach this. Because the way other teachers teach this can be wrong. It can be right, but it can be wrong sometimes. But I'm going to drop some knowledge on you. I'm going to show you the way that it will always be right. Lana said shade left, and I agree with it. Eventually, I will shade this on. Do better. We have an open point, and I agree with her. I'll go ahead and do it just for her. I'm going to shade the left side. But why is it the left side? Well, some kids will tell me, it's because it's a less than sign. And less than signs go left. I don't like that justification. No me gusta. What? Another one that's become more popular as the years go by, I see more and more kids giving me this thing. Hey, my teacher taught me, Roseli, that, hey, look, think of that sign as an arrow. Ooh, I even drew the arrow. And that arrow is pointing left, so therefore shade left. Well, okay, fine, but see, that only works when the variable's on the left. And I worry that, well, if the variable happens to be, I'm going to give you some with the variables on the right. What are you going to do there? So the only justification that always works, and it lets me show off my artistic skills, okay? When I still remember when I was in elementary, and the first time I ever met eyes with an inequality, my teacher taught me that, hey, it's an alligator mouth, okay? And the alligator has two choices. And alligators are hungry. They have big chompers and they're hungry. So if you give an alligator a choice, it's always going to pick the bigger of the two. Now, I don't do a very good job of drawing alligators. I'm still working on my alligator art. But an easier thing to draw is Pac-Man or be gender for gender equity. Miss Pac-Man. So Miss Pac-Man is also quite hungry. So if you give them a choice, they're gonna eat the bigger of the two. And if you also understand that shading means solution, what you shade is your solution. What are you solving for? The variable. So shading means variable. So look, mouth eat variable, variable big. Where do big variables go? Or where do big numbers go? Use your words. On a number line, where do big numbers go? Use directional words. To the right. Mouth no eat variable, variable no big, variable little. Where do little numbers go? To the left. So in this case, is the mouth eating the variable? No. So therefore, go left. That's the only way that works universally, regardless of where the variable is. Please. Hold the applause. Tengo razón. I just said a slur about hope. It's esperanza. Yeah, it is. That's pretty good. Much better than hope. No, I'm just kidding. No, we like hope. All right, hope. I'll let you take care of this one. Opie, this one solved.
-6.
You're boring long over here. Yeah, good. -6 on both sides. Oh, whoa! Easiest lesson ever. Should have covered this like way earlier. Even Emilsi wants to chime in. Ask and you shall receive. Emilsi, now that we've solved, we want to give a graphical representation. What is the critical point? ¿Qué número quiero enseñar en el gráfico? She does. Me puedes contestar en español, está bien. Diana's going to answer that. It's too hard. I can't. You're asking me to read the number on the board? No. Oh, thank you. I thought you said no. 4, yeah. But in this case, 4 is not my solution. 4 is just breaking the number line into 2 parts, into a left and a right, a yes and a no, a good guy and a bad guy. It's acting as a divider. But we need to know what side that 4 is going to be considered part of. So, Roselyn. Am I going to put an open? Like what's going to happen at the 4? Open point or a closed point? And cerrado. Or easy. That is going to be closed. And then the $1 million question, which is the hardest thing ever. Sarah, what side are we going to shade? Why left? Because Maylee said so. Why left? Go, Nico.
The variable is bigger than the 4. Thus, all the numbers to the right of the 4 are bigger.
Wait, no, the variable is not bigger than 4.
I'm retarded. My bad. I'm retarded.
No, don't use that. Yeah,
4 is bigger than the variable.
If you want to say that you're so Nicholas, you can just say that you're just being Nicholas.
Going to the left and it cuts off.
That's way too many words.
The variable is shorter than the 4, basically.
No, you just be concise. You're being verbose. Be concise.
Less than the 4, and that's all the 4.
Just say mouth no eat variable. That's it. No, but I want to know why left. Sarah said left, but Sarah couldn't tell me why. We want to know why. Okay. Yes. Mouth no eat variable. Good. Ooh, me hungry. Look at my chompers. Behind door 1, we have an N. Behind door 2, we have a 4. And it's like a an all-you-can-eat feast, and the Pac-Man has a choice to eat whichever one they want. Which one did Pac-Man choose to eat here, the N or the 4? The 4, right? So when given a choice, if the Pac-Man chose the 4 instead of the N, it's because the N wasn't big enough. N is small, and if the shading is for the variable, where do small numbers go? Where do small numbers go on a number line? Facts machine.
Why is there always one?
Frick. No, we cannot. Jocelyn will take this one. What do you want to do first, Jocelyn? Dale que tú puedes. No. No, she said minus 3/2.
Oh,
Yeah, you gotta add 3/2.
wait, see, my description's better.
Esperanza. That's like it.
Oh,
So, yeah, just treat it like an equation, man. This is awesome. So P's by itself. Why you stop? Man, this thing is acting weird today, and I don't like it. Hope it's all your fault. Apparently. You're an arrow. No, it's not that. No. I'm supposed to, because that's just gonna send it to the other side. If I do that, see, it went that way. You're an arrow. No, let's go to the next slide. That's tough, man. That's tough. Que vuelta. There we go. All right. So because the denominators are not the same, I like to add an extra step where I just write them horizontally. It's 10 seconds of my life that I'll never get back, but it's well worth it because now I can look at it and say, hey, what's the least common denominator of 5 and 2? It is 10. 5, 5 times what gives you 10? 5 times 2, so 3 times 2 is 6. 2 times what gives you 10? 3 times 5 is 15. And then 6 plus 15 is 21 over 10. And you're like, but man, how am I supposed to graph that? Well, if you had to graph this on a traditional number line, you would probably just divide and get 2.1, and then you know that 2.1 goes in between 2 and 3, just so obviously a lot closer to the 2. But luckily, we don't even need that because Papa Romero only asks you to graph 1 point. Maylee, what's the critical point I'm gonna graph here? Maylee. You are Shirley. This is Maylee. It is 21 over 10. And Hope comes in out strong with a closed dot. Good. Maurice, left or right? What? Why right? You want to help him out, Rosalind? Why? Mouth eat variable. Variable big. Big numbers go to the right.
It looks like an arrow, so if you just drew.
Oh, you mean kind of like the arrow that I drew already? Like that? Oh, you were in the potty? Well, don't worry about it. I got something for you then. I will not call on you until the time is right. You don't like this one? Well, I wasn't going to call you anyways. Rubén! What do you want to do first? ¿Qué hacemos primero, Rubén? Muy difícil. Mucho esfuerzo. Cassandra, what do we do first? What? I will, but not first. Isaac? Correct. Taiwan? Taiwan the chef? Darío, you know, what do you want to do? But I don't want to call you until the time is right. It's not right. It's not right. Nico, you know what to do? In less than 5 words? That's already too many words.
Just so you don't know.
When you're, I know what you have to do because like, just like turning mix number two and
There we go. But when your language arts teacher is using them already,
I'm sorry.
do you spend like 2
He's
paragraphs?
talking about the standings.
What?
Don't worry about that. Don't worry about
Okay.
That's not nice. So 2 3/5 is an improper fraction. It's 13/5. John O, what do you want to do next? Good. Subtract what? Good. And since the denominators are already the same, you can just borrow 3 toes and do 13 minus 3. 13 minus 3 is 10. And what's 10/5? 10 divided by 5 is 2. You're 21. No, it's just 2.
Wait, why did you put it 2?
Because 10 divided, here you go. This extra step goes out to Jason from his teacher. The struggle is real.
Oh, it is 2. Because you. Oh.
The extra weight you feel is me dropping knowledge on you. Okay, now it's time to graph. Soha! What is the critical point here? Critical point? Critical point? It is 2. I just can't hear you and I couldn't read lips either. And then what's going to happen at the 2? No, at the 2, not left or right of the 2. What's going to happen at that 2?
Oh, it's gonna go.
Shushishush. Shushishush. Soha doesn't want to speak. Sarah, you want to help Soha? And then you can start, like at the end, you can call it S squared or SNS. That's what all the kids do. Can we get to Sarah? Open or closed? It is going to be open. And the $1 million question, unless Your name is Emma, in which you will have to reserve judgment. Are we gonna shade left or right? Why to the right?
Because the mouth is even.
Good, mouth E variable shade right. No, Mr. Romero. In an act of defiance, I will draw an arrow on my paper and I will do what the arrow tells me. Hey, Emma. Hey. How would I isolate the variable here?
Would multiply.
You're on a roll. Good. The opposite of dividing by 4 is multiplying by 4. Sweet. And that cancels out, and we get negative 12 is less than 6.
February is severe weather month. At this time, we are practicing our severe weather drill. Teachers and students, please turn in your correct places. Thank you.
Yeah, so we have to like go on the floor. Okay, it's not okay.
Like in kindergarten.
Changing the
Windows decline. Yeah, if it was a tornado, then you have to like duck and cover. But Xavier, you get on your desk if you want.
Your name is Xavier?
You wish it. That's a sacrifice we're willing to make. All right, so Emma, I helped you out, Emma, and Emma, I helped you out by writing that 4 times negative 3 is negative 12. But now you're gonna take care of the shush. Emma only. Emma, what's my critical point here? It is negative 12. Good. And what's gonna happen at the negative 12? Yeah, open or close,
It's going to be open.
It is gonna be open. Oh, see, awesome. Where are we gonna shade? But Mr. Romero, the arrow is saying go left. And I do whatever the arrow tells me to do. Has nothing to do with the negative. Go ahead, Elsie. Drop more knowledge on her. Mouth eat variable. Variable big. Now, Elsie is foreshadowing a bit because Elsie is fixated on the fact that the 12 is negative. But I can assure you that what you see on the board is correct, but just keep that in mind. We do want to pay attention to some negatives, but everything on here is correct. Emma's plan of doing what the arrow tells her to do backfired on her. Well, she probably had good intentions, and as long as Miss Godfrey gave you problems where the variable only stayed on the left, then the arrow thing works fine. But it's when the, and I would assume that she taught you also some way to fix this to move the variable back to the left. Some teachers teach like, oh, well, just think of it like a mirror and flip it back so that the x goes back to the left. For me, Old Faithful, what always works is just the whole mouth thing. I learned it as an alligator, and then over the years, due to my artistic ability, it's moved itself, shifted to, you draw an alligator.
No, go to the board and draw it.
No, you draw it. Ooh. Elsie's moment is here.
Okay, I'm gonna watch the recording. If you do that,
I'm gonna posted just for you.
Okay. Scared you're an alligator. Me too.
I've been referred to as the songbird of my generation.
Eyeball.
Okay, how do we isolate this variable? You could. Somebody last period actually impressed me that showed me that they remembered how to do it in one step. I showed you how to do it in one step during equation time. And
Okay.
your thing of multiplying and dividing would work if you wanted to do it like in 2 steps, but if you want to show off for the ladies and do it in 1 step, you can do that. What is that negative 3 over 2 doing to the x? It is doing something. What's it doing to the x? I'll give you a clue. It rhymes with multiply. It is multiplying. So, Xavier, remember there's a severe weather right now. You need to be sitting. No. Sit. You guys can hug it out later when the weather gets better. How do you cancel out multiplying times a fraction? Yeah, but you can't divide fractions though. So we learned an alternative. Soha, what'd you say?
No.
That was Rosalind that said something? Oh, I thought it was Soha. What'd you say, Rosalind? Oh. I'll give you a clue. It starts with R and ends with reciprocal. Yeah, you multiply by the reciprocal. What's the reciprocal of negative 3 over 2? What is the reciprocal of negative 3 over 2? Negative 2 over 3. So by rule, when you multiply by reciprocals, they cancel out. So we have x by itself. On the other side, unless you're in mean C and you're advanced with those fractions, you might not like them. Mean C loves fractions. So what's positive times negative? Negative. And then you can either cancel out the 6 with a 3, or you can multiply 6 times 2 is 12, divided by 3 is 4. Okay. So now listen very carefully. I do not care. It should be open. You're locked.
Hello, teachers and students. Thank you for your participation. The drill is complete. Thank you.
Click their heels 3 times and sing it's like home. But they'll make it back fine. Okay, so listen very carefully, because here's another source of confusion. There's the whole shading fiasco that we always have to overcome in this. It does not matter that I ended up with a negative. So your fixation on the negative being there the last time, not a big deal. It does not matter that I started with a negative. The only thing that matters is what I did to both sides. What did I do to both sides? Well, I multiply, so I multiplied by? Okay, well, it was a fraction, but that's not. I multiplied by a negative. So here's where we stretch out our writing muscles and write this down so that we don't forget. In an inequality, that one little difference that I told you about at the beginning that's coming into play now is if you ever multiply or divide by a negative, on the next line, the inequality sign flips.
Yeah, that's what I was talking about.
Well, if you don't know, now you know. Because 6 times 2 is 12 divided by 3 is 4.
4.
Because anytime time you hear those words come out of my mouth or anybody else's mouth, if you multiply or divide by a negative, then the sign flips. In this case, what did I do? I multiplied by negative 2 over 3 on both sides. Yeah, it has nothing to do, yeah, just, the only difference would be if the little line wasn't under, when you flip it, it still wouldn't have the line under. Taiwan, flirting is best done after school. You can get those digits. What's the critical point here? It is a negative 4. What's going to happen at the negative 4? It is going to be closed. And are we going to shade to the left or to the right? Why left? Mouse no e variable. Okay, just a quick one, another one stepper. What do we do here? Hope, cope, so, rope. Divide by 4. Oh, look, we divided, right? Since we divided, now that means I'm going to flip the sign. Don't say it, because I did not divide by a negative. We maintain the status quo. Number line. What's the critical point? 3z for sheezy. What's going to happen at the 3? It is going to be open. And are we shading left or right?
Down.
As Beyonce and Taiwan once said, to the left, to the left. Because mouth no e variable. Variable little. Ooh. What do you want to do, Maylee? Good. Listen to what she said. Divide by negative 7. I don't care that the 17 was already negative. Look, negative divided by negative is positive. But I don't care. But I to both sides, I divided by a negative. It will flip. Because the or equal to sign was there, it's still there. The struggle is real, let me see. Es verdadero. What's the critical point? Yeah, let's put 17 over 7. What's going to happen at 17 over 7? It is, and then Emma agrees. Left or right? Learning curve. Why to the right? Mouth e variable. Ooh, I'm hungry. All right, last one. You don't say that again. Come on, last one. Let's get this one done. No plus. Shh. -6. Good. Oh wait, look. It's a negative, so the sign flips, right? No. Because all I did was subtract. What's the last step? No. Spaghettios. We divided by a negative, so P less than or equal to 5.
It's close, and it goes
Yeah, on the second step. It's not on the first step. On the second step, it flips. So close, and then a la izquierdo. To the left.